Okay, as mentioned, I'm Chrystopher Nehaniv here from the University of Waterloo. I'm also in the Systems Design Engineering and Waterloo Institute for Complexity and Innovation. I am a mathematician by training, so I don't have the traditional economics background, even though I'm talking about currencies. I have some biology background. I work at things like modeling multi-scale systems and gene regulatory networks, but also various other areas where complex systems mathematics can be used. Some of this work comes out of research that we did in Europe, funded by the European Commission under the Framework 6 and Framework 7 program, Project Biomix, and also Horizon 2020, a project Interlace that has to do with complementary currencies to the euro. So a particular complementary currency called the Sardex unit that I'll talk about, which is a currency on Sardinia. And I have to acknowledge, I'm interested in getting people to think about these ideas. I have to acknowledge lots of stolen ideas, okay, from colleagues like Paolo Dini, Keith Heipel, who spoke here a couple of days ago, Giuseppe Lutera from Sardex, Matthias Grasselli, who's discussed some of these at the Fields meetings that we've already had on climate mathematics for climate change, complexity, and doing something reasonable, trying to do something reasonable. So I'm quoting my friend Giuseppe Lutera here. This is a very striking quote for me that really changed my way of thinking about things, that our early human ancestors invented the wheel, and they got the design of that right. But money is a different story. We're still working on that one. So we don't know how to design money, and we're still changing money all the time. And you may be surprised about some things I'm about to tell you about money, because I didn't know these things before I came in contact with Sardex, or that even these kinds of things were possible, that you might imagine that you put your money in the bank and it stays there, but actually only a fraction supposedly stays there, and it can be loaned out while you have the same balance. And so you are, the bank is effectively creating money when they give somebody a mortgage loan. So that's one of the things I didn't know. And I think the general public doesn't know these things about the economic system. This is actually line by line. I have some quotes about complex systems. These are just in Wiki, we use lots of methods that are for complex systems. And just to have some information about that kind of general approach, where there are different techniques. To quote my department, which is about 50 something years old, a system can be defined in its most general form as a collection or assemblage of items united by some form of interaction and interdependence. Systems design engineering is a study of complex systems for purposes of analysis, simulation, optimization, and ultimately design. So we want to think about how to design currencies, potentially, or financial mechanisms to get the results we want in the world of climate change, which is very pressing now. It's why I'm not interested in this topic at all, because it's very concerning. We've heard a lot of the projections, and IPCC is saying things like, for most of our trajectories, if we reduce emissions, we just reduce emissions, we're not going to meet the targets under most scenarios. We have to actually go, we actually have to have negative carbon production or carbon sequestration, pulling carbon CO2 out of the air, and pulling greenhouse gases out of the air. So how can we engineer that kind of thing financially in a relatively painless way that people are going to buy into and participate in? Okay, so with complex systems, there are various methods. We use mathematical methods, modeling methods, game theory. Keith Heipel gave a fascinating talk about extensions of game theory, methods for using graphical methods for conflict resolution that go way beyond kind of a Nash equilibrium type of analysis. So those are really exciting methods that can be applied to this problem. He's done some work there. Systems theory, agent-based modeling, to get into the effects of and strategies and understanding of mitigation and adaptation and so on. So there's a plethora of techniques that colleagues might not be aware of. Okay, this is a diagram here from my colleague, Professor Heipel, that in considering something like carbon change, we have to consider systems of systems where there's not only profit margins, profit and utility, but there are different actors and different types of societal realm, and also the realm of natural physical systems. So we don't have much time, but these systems are inhabited by decision makers with conflicting value systems, there's uncertainty. They're very difficult properties to treat by traditional methods. If you try to do the differential equations, solutions, and existence and uniqueness, you're going to have to go beyond those traditional methods. So thinking about other types of currencies, it's good to look at our existing currencies. And if you just think about the US dollar, it was backed by a gold standard. So you could go and redeem your US dollar and say, give me $1 worth of gold in the bank until 1933, right, Great Depression, Credit Emergency Act. You could no longer exchange your dollars for gold. In 71 was the end of the gold standard. And then after that, the US dollar has been a fiat currency. Fiat means let there be, in the sense of let there be light in Latin. So it's let there be money, right? And it's not backed by gold, it's backed by the full faith and credit of the US government. It's legal tender for all debts, public and private. It's not redeemable anymore for any underlying commodity. Okay. And we also had in the US, we have a fractional reserve system where if you put your money in the bank, say $100,000 and get 1% interest, it'll be very bad rate. But the banks had to say could keep some percentage on reserve and can loan out the rest. And so your bank will still show you have this balance, but 90% can be loaned out for mortgages or other purposes. Okay, so and these requirements for this reserve quantity, this reserve fraction. So the money is actually be created by the bank, okay? And it can go to another bank, and that bank can create money. So you get this cascading effect. So a lot of money is being created sort of out of nothing, which is most people without this background, which I didn't have, will be. I was quite shocked to learn that what's going on here, right? And actually, at the beginning of the pandemic, March 26th, this requirement for a reserve ratio used to be 3%, 10%, depending on the size of the institution, has gone down to 0. I'm surprised I had not heard about that, but it was not in any news that we had. So that's been replaced by interest being paid to banks on reserves as an incentive for them to keep some fraction of the reserve. But they don't have to do it. It's voluntary. Okay. We can think about the dollar has this kind of history, but we can think about other types of currency. So we have Bitcoin, which is backed by a proof of work protocol where people mine Bitcoins and they're duplicating each other's effort. They win a competition. It's tremendously inefficient energetically. The electrical energy requirement for Bitcoin is huge, and the great majority of it is wasted because only one of the servers gets to win that race. So actually Bitcoin's in effect is being backed by environmental degradation. So this is not a very good design for a currency if you want to consider the climate impact. Okay, but there are other types of currencies that can coexist with our usual fiat currencies. And one of them is the Sardex unit, which is what I want to talk about. So this is on Sardinia. After we heard today about the financial crisis of 2008, where Sardinia, which is a relatively poor part of Italy, introduced, or Giuseppe Laterra and his friends introduced a complementary currency, one Sardex unit equal to €1. And although they couldn't get loans from banks, money was scarce. Banks wouldn't want to take any risks at that time. Everything had fallen apart. It allowed small, medium enterprises and local businesses to create their own currency backed by their own reserve production capacity. And so this was designed to have a zero interest on this mutual credit, so that it would be robust to any kind of attempts at extractive exploitation. And it succeeded in helping Sardinia get through the aftermath of the financial crisis, and it's there and still growing and robust to this kind of external, because you can only spend this currency on Sardinia, right? And you can be paid part of your wages in Sardix units. You can buy coffee in Sardix units, but you could also give loans to other businesses based on you do what you like with the currency within the circuit based on your own production capacity. So it's backed by something. Okay. So the second point is that we talk about gold as the backing of currency. Second point is we really have to, when we're designing systems, any kind, we have to look at values, because if you have pathological values underlying the system, you get pathological outcomes. So if we look at Canada, France, healthcare, we have relatively ethical values, universal healthcare, equal sharing of risk, everybody pays the same, and you have a robust society. Whereas in the US, the values are a bit more distorted. There's profit maximization. Ill people pay more, right? And frequent bankruptcy is in the US is rampant due to medical expenses. So it gives you a much more unstable side. There are other examples of electrical system failures that I learned about from Keith Heupel, where 7 US states and parts of Canada, including here, 14th of August, 2003, huge, all electricity stopped, right? Because the underlying value is to sell to the highest bidder for profit maximization. So, and to spend power over long distances where there's a demand for it. And this caused overloads and attempts to do physically impossible things, which crashed the electrical system. And that's the ideal there is the ideally we should have is to provide low cost, reliable electricity to all citizens, right? So, and lots of similar cases. So profit maximization by big pharma leads to opioid crisis and other pathologies. So there are ideas for addressing climate change by introducing carrots and sticks, and one of them is a carbon tax. This is a particular proposal from James Hansen, 2009, fee and dividend. You can see some of the details here. You tax carbon production at the source or for sale. You divide the proceeds uniformly amongst the population, and you negotiate tax level for each nation, and you increase this tax over time to be able to control the level of carbon emissions and drive it down to ensure our survival. And various adjustments can be brought in. So let me, so there are various different ways of designing currency and underpinning it with different values. Okay, so let me just go ahead here to talk about a little bit about carbon currency design space. So things like you've heard of cap and trade, which just shuffles the right to pollute amongst different emitters with a cap. Okay, so the underlying value there is this thing that you want to be able to pollute with. So that's kind of backwards. So a different kind of value you could base a currency on is removal of carbon and other greenhouse gases from the Earth's atmosphere. Removing carbon from the oceans is another way. So directly from the atmosphere, which is where it's a problem. If we remove carbon from the oceans, we can, they will absorb more carbon. The oceans are a huge carbon sink. Okay, there are different approaches to do that technically. Okay, so this idea is we've seen that you can sort of pull the carpet out from under the backing value, right? So the value of a currency can just be backed by the full faith and trust of a government. So if individual countries or a global authority backs a currency that has that as its value, or even maybe at a more local level, CO2 currencies could be created for this, simply for this kind of action, taking carbon out of the atmosphere, right, and sequestering it for 100 years, say, for some kind of basic unit as a first approximation. And but we need to monitor transparency, compliance with things, possibly with blockchain technologies, and so on. So there are issues about I won't be able to talk about these, interconvertibility of designed to avoid fraud, greenwashing, and also harmful pathological extraction. If you did something like cut down a forest to sequester its carbon, right? This would be not what you want this for, or enhance oil extraction, which is actually one of the ways that carbon extraction from the atmosphere is currently being used to improve the efficiency of extracting oil from underground with direct air capture currently. So, but we need to be removing 10 gigatons of carbon per year in the next few decades, and 20 gigatons a year in 2029. We're not anywhere near that, and it's there are some government subsidies, there are investors that are interested in doing this, but we need action at a more global level, at a policy level of nations. Okay, to implement something like this, because I have a quote coming later from Matthias Honegger. He says, you don't want to leave sewage treatment to volunteers who are going to do it out of their goodness of their heart. So we've got to clean up the air. So we need high-level, government-level movement on this to put into place mechanisms that are going to pull carbon out of the air. So things like these types of carbon currencies. So there are many stakeholder issues. So here are some ways that it's currently being done to remove carbon from the atmosphere. It's still very small scale. Under the Biden $2 trillion climate investment plan and Inflation Reduction Act, there are tax credits, but there are also 4 direct air, 1 megaton per year carbon removal extraction plants being built, which should be before 2030. But we need 250 times more that. So we need 10 gigatons, not 1 megaton a year being extracted. Okay, so I think should run out of time. Running out of time here. So there are different things that could be rewarded by these kind of alternative currencies, such as reforestation. But if you wanted to solve the problem with just that, you'd need to, if you totally covered the US or Europe with trees, it still wouldn't be sufficient. So we need this kind of a technology deployed. Also, extraction of CO2 from seawater, different techniques for doing that, and the costs of those is coming down. And then the sea, because it's a carbon sink, would absorb more of atmospheric carbon. We have to develop methods to quantify that and reward it. So just if we think back a bit further, 2.5 billion years ago, the Earth was had a very radical climate change that occurred because of photosynthesis. Photosynthesizers were producing oxygen as a waste product. It's very poisonous if it gets in your cells and your DNA. We talk about taking deoxidants and green tea against that, right? But if you there's this O2 pollution, and then it was the O2 was sequestered in the oceans because it bound with iron, sank to the bottom of the sea. But people kept microbes kept photosynthesizing and polluting the world, and so all of the iron went out of the sea, and then it started to go into our atmosphere, and that's why we have 21% oxygen today. But there was a discovery of not only, so this was producing this gas, but there's another mechanism that was discovered by Darwinian evolution, which is respiration, to pull the oxygen out and use it in making metabolism of sugars much more efficient. Okay? And that's what we're descendants of that situation. So we should stop soon. Okay, maybe I've said everything. A few minutes. Okay.
And just because we had a bit of a change in our schedule this afternoon, our third speaker will be joining us probably in another 5 to 10 minutes. So what we'll do is we'll let you finish up, Chrystopher, and then we might take a few moments for some questions and answers ahead of our next speaker.
Yeah. Oh, so here's this quote: relying exclusively on voluntary action. So companies and philanthropists, Microsoft is getting into this, Bill Gates and Meta and and various companies into this technology and developing it for extracting carbon from the atmosphere and doing sensible things with it. And that needs to be thought through in much more detail. But so we can't rely on this kind of just goodwill to fund the solution to this problem. We need effective and fair removal of CO2. So this quote from Matthias Honegger. Otherwise, we're trying to fund something like public sewage systems on donations. So we need to consider multiple carbon currency designs, local, national, global, so they can be modeled and evaluated. And techniques like multi-scale mathematical modeling, conflict resolution, graph model, and so on, can be brought to bear on it. And I think a lot of people will have other techniques they want to bring in. And so this kind of policy, economic, and ecological challenge demands actually a critique on different interpretations of value. So I hope I've conveyed that how we think about value and money is up to us. We can change it. Yeah? In currencies, in any kind of currency design, actually including carbon currencies, and to target the niches to develop, we need to consult different disciplinary traditions, mathematics, economics, political science, so on, philosophy, ecology, and in tandem also bringing in different ways of knowing, indigenous ways of knowing, that provides really valuable perspectives in order to resolve the kind of existential risks we're facing as a species, with things like the danger of the ice caps melting and then releasing so much CO2 and methane that it'll be just swamp our current troubles, right? That it'll be irreversible. So, okay, I'll stop there. Thank you.